All right, welcome back. Let's write some unit tests for Godot. So last time we talked about the why of the unit tests, and we also talked about how to set up XUnit for Godot with C#. Perhaps you chose GDUnit. That's also an option. There's a few others out there. The syntax might be slightly different, but the ideas will always be the same for these. They're not extremely complicated libraries as far as that goes. So we're going to start with writing some really basic unit tests, like tests of your little math functions, that kind of thing, just to get a sense of the very basics. These are often things you do want to test anyways, and they're very easy to test. There's some challenge if you have a node object or an object that's got some integrations that you're dealing with, and I'll talk about that a little bit too. Then we'll deal with a much more complex situation where we have a pathfinding algorithm using A*, and I'll go over how to write tests for that, and I'll talk about how that actually writing those tests helped me find a bug. So that's kind of the best case scenario here. The tests don't catch anything, or at least they do catch something while you're actually writing, and it makes your code better in general. It never breaks. Cool. So let's have a look at our code. Sweet. So here we are. This is where we left off. We're in example game 2000. We have this a CS proj that we made for the unit tests. This is the place where we're going to put tests. We also have a sister or brother sibling project, which has the actual game code in it. We have, if you remember, added a reference to the game code, so we can reference the classes from our game code within our example game project. And if you remember, we should have this little testing, I'll move this over a little bit for you, little testing drawer here. And say, it's a little sneak preview. We have one test finished for this already, which that works. It was passing, and we can make it fail if we give it a false equals here. Excellent. This is great. And notice when we get a failure, we get a actual description of the expected value versus the actual value. This is how we improve our tests, find bugs in code, catch bugs other people have introduced into our code. We can catch them using this process. Awesome. Okay, so first thing, let's make a new test. Let's first look at what we want to test. So I've got this game math class here, and we're going to go over this one really quickly because these are really easy. And we'll just get used to it, and we'll be able to write these tests super fast. So let's just, I'm going to put this to the side for now because we're going to copy it, copy the syntax, but we can delete it because this is not, there's nothing called unit test 1. We should be more descriptive. Okay, so inside of example game 2000 unit tests, we'll make a new folder. You can get very organized with this. Since we only have a few things to test, I'm just going to call it tests, or maybe scripts to match the how this works. And then in here we can put game math tests.cs. Okay, cool. I'm going to hide the file view here so we can look closely here. So first let's look at, we want to set up the kind of infrastructure for this. So we'll give it a namespace. I think example game 2000 unit tests is just fine. And then we want to make a class, and we'll call this game math tests. And then what we see here is every test is going to start with this decorator, fact. There's also theory, which we can talk about later, which is a really cool way to run a bunch of facts at once, but fact is a good start. And we're going to call this unit test, well, let's just call it test for now. Okay, so how we use it, we can name these however we want. They'll just run if they are under a fact. But a really great way to name them is something like this. Game math, let's see what we're going to test here. Add. So game math add. So this is just the context in which it's running, or the name of the function. Then we want to talk about what arguments it's receiving, or maybe variables in its environment. But in this case, it's just two arguments, int A and int B. So 2 and 2 should return 4. Fun. Okay, cool. So in this case, what we're going to write is assert equal. The first number you put is going to be the result you expect, so 4. And then you want to actually do the test, so gamemath.add 2, 2. Cool. Okay, so this is just going to test this class. We've actually already tested this, but let's run it again. We'll open up our testing drawer. We'll do a refresh to get that one. And then we will click on this to run it. And it works. This is great. I'm now going to delete unit test 1 because this is not testing anything real. Okay, great. Okay, here we're in game math tests again. So add is the simplest function in the universe here, pretty much. Is there anything else we can really test with this? If we wanted, we could test conditions where we gave them really big integers and made it integer overflow. If we do, I guess, over some billion. That's fine to do, but really that's just testing this operator. We know how that works. We know that's going to happen. And in the case of a game, you may not need that level of serious unit testing for such a simple function. So let's move on. We'll say that this is tested. Let's talk about divide. So here we can put all the tests for game math in the same file if we want, if they're simple enough. You are free to split them out too if they become more complicated. But let's do some division here. So public void game math divide. Let's remove this so we can see more. Game math divide. What should we divide? Let's divide something simple here. Let's divide 4 by 2. Should return 2. Love it. I mean, we know what's going to happen here. 2 game math dot divide 4 2. Awesome. Let's leave that for now. What about a more, I don't know, irrational, I guess not irrational, but what about a number we can't easily represent with a float? What if we try to divide 1 by 3? What's the result that we should expect? Like, 0.33. Should we, how do we express that number without just rewriting this whole function? So there's a complication that anyone who's worked with floats understands, in that they generally, after a certain point, aren't quite what you expect. So we can try something like this. Assert dot equal 0.333333f, and then do game math dot divide 1 3. Well, let's see what that's going to do for us here. So if we go to this and we regenerate these, we'll check this one first because we know that's going to be good. Okay, that was our 4 by 2. But now let's run 1 by 3, and this is going to fail. And we'll look at the failure. And those numbers aren't what you expect at all. Like this, we did not specify this weird ending, and it's certainly not that. So one issue that we're going to run into here is an issue with accuracy. And there is an easy solution to that, and that's that assert equal can take in another value that is its tolerance for how much off it can be. So we can do something like this. We don't need that many. We don't, with game development, we do not actually often care about the 20th decimal point, depending on what you're doing. If you're building a spaceship for NASA, you might want to care about more. But we can put a number here like 0.01, and this should say that if it's off by this or less, we don't care, it's still a pass. And run it, and it's good. So that's another really important thing to remember. If you're doing any comparisons with vectors, like vectors with floats or floats themselves, those will require a tolerance. Awesome. Okay, let's do one more. And this is kind of a weird case, but what if we divide by 0? Let's divide 2 by 0. Should return something. What do you think is going to happen here? And we are just writing stuff and then running the tests and seeing what the values are, and then updating the test based on that, and that's okay to do. Really, these tests codify what you expect, and sometimes you have to write the test to understand what you expect. But cool. So we got insert equal. Well, I don't know. 10,000, and then we do game math dot divide to 0. If we run this, what I expected actually the first time I wrote this is I thought it would get an exception, like it would throw an error, but it actually doesn't. And it's a weird thing with C# in that if you divide by a variable 0 and not a constant 0, a variable, you will get infinity. So we can actually test for that if we want. Inf mathf.inf. So let's run this again. And it's happy. So again, if this is something that is going to, like if your divide function should never hit infinity, you're going to want to introduce an exception and test for that. But naturally, C# will give you an infinity if you divide by 0. Okay, cool. Let's look at this last bit of this, and then we can move on to more interesting stuff. So this add arrays functions takes in 2 arrays of integers, and then we'll add them based on their index. So if you give an array of 1 and 1 and 2 and 2, you'll get an array of 3 and 3. So the basic thing we can test here, or why don't we look at it through like the branch perspective. So the first thing is if these do not match in length, we throw an exception. So we can test that, and then we can test like the happy path here. So let's do that. So you can actually test for an exception too. So public void game math add arrays we don't have to actually write the exact values of the arrays. We can just explain what they are. So different sizes should throw exception. Splendid. Okay, cool. So that's that. I put some garbage there. Okay. So we're going to add 2 arrays of different sizes, and we're going to expect an exception. So I think it's assert.throws argument exception, and then we're going to write the code. It actually needs to be in a little bit of a block, an action block here. Weirdly, but then all you have to do is add array or game math dot add arrays, and then we're going to put our 2 arrays in. I'm going to put in an array with just number 1 and an array with number 2 twice. Okay, so that's what that looks like. Again, yeah, it needs you to put it into this little block so it can, I guess, invoke it. Let's pick up the test with this and then run it. Beautiful. Okay, cool. Now, let's do the happy path for this, and then we can move on to some more useful code. This is really just to introduce you to some of the ideas of unit testing, some of the tools, such as assert throws, such as the tolerance, and just the assert equal. Cool. So the happy path of this is that you send in 2 arrays, it adds them piecewise, and then it gives them back to you. So public void game math add arrays. We'll do 1 1 plus 2 2 should return 3, 3. And again, I mean, obviously these could be a bit ambiguous out of context, but whatever, right? In context, they make perfect sense. So assert equal, and then we want it to be 3, 3, and then game math dot add arrays, and then the two arrays we want are 1, 1, 2, 2. Okay, cool. It seems to be happy with that, thankfully. Let's pick up everything here and run it, and it works. And we can just test that it's actually working by making it wrong, and then running it again, see what happens. And it fails, so it is working properly. Cool. Okay, so that's the math classes. Next, we're going to look at something probably a lot more useful. Cool. So the next one I want to show you how to test is some game object. Okay, so this is a object. It could be a node in your Godot scene, or it could be any other object that's got some level of integration here. And by that I mean there are calls to other stuff that's not related to the function. So have a look at this, and we've already kind of talked a bit about how some things are not really worth unit testing. Like I wouldn't unit test setting and getting these values, except for we could test these functions, which are, I guess, kind of setters or getters in this case. But there's an interesting wrinkle here that I will show you. So let's quickly make a new unit test file for these. We're going to call it some game object tests. We'll move that over here. If you remember, we will namespace it. New game, example game, and then public class, some game object tests. We start with a fact, and the fact is, let's first test quickly this increment number, just to show you kind of how we can unit test with an object that isn't returning itself, like it isn't a utility function. So some game object, I wish I named it something briefer than some game object, increment. And then since there isn't really any context for this at all, I guess we do from 0 should be 1. Okay, let's hide that. Okay, great. Oh, it has to be void, obviously. Here we are again. Cool, so let's do increment number. Really, there's only one thing to test here. That's to test if it increments it. So we can write more things than just asserts in here. We can use this as normal code. So we'll make some game object. Obj equals new some game object. Does it like that? Oh, okay, yeah, it wants... Oh, yeah, it needs to get its values. Oh, yeah, see, it's got its the simple constructor up here. So we have to pass it some values in here. So we have a name, we'll call it Billy. And we have a number, we'll call it 0. And then we have something called an iEvent service, which we'll call null, because we don't have an event service here. This is some sort of, and it doesn't matter in this case because it doesn't do anything, but it's some sort of external service that you have attached to this, which is a pretty common thing in a lot of this code. Cool, so we've made an obj. It's named Billy, and it's got 0 of whatever the number is. Okay, so how do we test this? Well, we can do obj dot increment number, and then we can write our assert equals here. 1 obj dot number, and that's it. Now, there's a really common pattern in a lot of testing, which we call arrange act assert, and this is an example of that. So arrange, we have created this object. Act, we have done thing to object. and assert. We have tested to make sure the object has the expected value. You'll see this all over the place. Sometimes people put these comments in code. You don't necessarily need to, but it's a good reminder. And sometimes if you find yourself writing code or tests where you are doing an act and then you're asserting something and doing an act and asserting something and then arranging something, it might be a good idea to simplify things to make sure that each test just has one arrange, or you can do as much as you want in this block, but it's all together, and then it acts, and then it asserts. Really complicated tests are much harder to figure out what went wrong. And let's do one more here. Let's test change name. So we'll call it some game object, change name to 0. No, that's confusing. It's a number. Xander should succeed. Cool. So there's an issue with this here, and I've already solved it, but your code may not have. So if we do not have this null coalescing operator here, and we ran change name, there's going to be a problem. So let's try that out. So we're going to just copy this whole bit here because we can, and there's no good reason to waste time typing. We're going to act. We're going to do obj.changeName to Xander, and then we're going to assert Xander obj.name. Awesome. Okay, cool. Let's run these tests. So if we do that, we should get the new tests. Beautiful. And let's just run all the tests quickly. It's pretty quick. Okay, run that, and then it does not work with that. And why? We get a null reference exception, and it points to the place in code, which is, of course, where it tries to use event service to send an event. This is a problem because we don't have an event service and we don't care about it. But we can fix that by, among other things, you could just put a null coalescing operator. So if you're not given an event service, you don't send anything. Otherwise, you could look into something like mocks, which are a bit beyond the scope of this, but are a way to put fake services, essentially, and fake stuff into your code that doesn't actually run because you don't care, because you're really just testing this thing and not its integrations. So if we run this now with the null check, it's great. And this should work now too. Yeah. One quick other thing about this arrays one. Some testing suites have a problem in that when they try to test the equality of two arrays, they say they're false because they're not the same object. XUnit will not do that. It will just test if it has the same values, which is generally what you want anyways in this case. You don't care that they're the exact same array pointing to the same place in memory. Okay, cool. So that's fun and good. What if we want to test something that like actually matters and is more complicated? So that's what we're going to do next. So what we're looking at here is a little Pathfinder service. If you're familiar with A*, I'm just going to make this full screen here. If you're familiar with A*, you'll understand what this is doing. But pretty much the idea is we give it a map like this, where it's like a two-dimensional array. Every one of these squares or tiles or whatever is represented by its two indices. So 0, 0 is here, 1, 0, 2, 0, 1, 1, or 0, 1, 0, 1, 1, 1, 2. It's hard to keep track of that. But anyways, so you can understand how this is a map. Each of these numbers represents how difficult something is to get by. And then the responsibility of this algorithm is to find the cheapest path to get from one point to the other. So the cheapest path from, say, this one to this one is going to be, well, it could be one, so it's 2, 4, 6, 8, 10, 11, or 10, 11. Both of those are good, actually. But it will make a choice. A simpler one like this, the cheapest path is going to be 2 or 1, 2. So like that. Anyways, and you can give it much bigger grids, but testing it with a small grid like this will be simple because we can see where things go wrong really easily. Anyways, so yeah, it takes in a grid like this. It takes in a vector 2i for origin. That's going to be something like 0, 0 for there. And a vector 2i for target, which could be something like, say, 2, 2 for there. And I'm not going to go over how A* works in this, but feel free to look through this code, reuse it, mess with it if you want. And at some point, maybe I'll do a video walking through why this is a really cool and useful algorithm that can be used for so much more than just pathfinding. But for now, the reason we are going to interact with this is just to test the inputs and outputs, kind of like a little black box, to see if we can make it screw up and find a problem. And if not, be very confident that it works exactly how we think it should. This is also the kind of code that maybe your co-developers might jump into and start messing around with. So if that happens and they get something wrong, which you can really do easily, our tests will hopefully catch that and they'll be able to fix it before they try to merge anything. And also, it's just way easier to test a lot of things with unit tests here, rather than make really complicated situations in your game to test something with pathfinding. Oh, one last thing, sorry, about this input here is that the negative ones just represent impassable stuff. Great. Okay, let's have a look at testing this. So it's going to be hard to test paths if we don't understand this, but we can write a bunch of tests and then see what paths have been hit. So let's start with just writing some tests. Okay, first let's go to scripts here. We'll make a new file. We'll say that it's called Pathfinder Service Tests. And then we are going to do the same thing as we've been doing the whole time. Give it a namespace. Example game 2000 unit tests, of course. Pathfinder Service Tests. And then we start with a fact. And the fact is going to be, well, what? What is a fact in this case? Well, what we're really going to be doing is making... Well, we'll drop a map like this, and we can just drop that somewhere in here. Let's just do void. We'll rename this in a second, but let's just get our ducks in a row, so to speak. So if we get integer here, oh, this is the worst possible way to have copied that. I apologize, but we're going to do a lot of copy pasting for this, just so we don't have to rewrite a bunch of semicolons, or sorry, parentheses, squiggly boys. So every test is going to look something like this. We're going to define a map. We're going to define an origin. And it could be 0, 0. I'll use that mostly just because it's natural to start from the top left corner, at least as an English reader. And then target equals, and we can end it wherever we want. We'll probably move this around a bit because on these really small grids, that can be a little tough. Okay, cool. What do we do now? Well, because it's going to be a bit of a pain to ever look through this code if you don't understand it, we can just kind of start reasoning about the kinds of things a Pathfinder is going to do and start writing code for that. So let's start with, I'm just going to leave this up here for now. and not assert from it. We'll just use it to copy from. So let's do one here where we expect the simplest thing possible to happen. We want the path to go from 0, 0 to 2, 0 here, I believe is what that one is. And so to do that, we can put some heavy terrain there and make that lighter. And so the expectation is that if your little guy starts here, it'll go there and then go there. Of course, I have forgotten to mention what the output is. The output is going to be, so we'll say it's a list vector 2i, expected path, and it's going to be a list of path points up until the target. So let's actually copy paste this down too. And let's name this one. It's going to be, let's say, Pathfinder service, find path. We can call it something simple, like simple path. Or I guess we'll do from 0, 0 to 0, 2 simple path. You could probably think of a better way to name this, but it can be a little hard. Okay, so we've got this, we've got that. How do we assert this? We'll add one more thing here, because the expected path is going to be, you'll find 1, 0, 1, and then 0, 2. Sorry, this is 1, 0, and then 2, 0. It's I always mix up my axes there. Cool, so new vector 2i, 1, 0. Okay. Thank you. Okay, cool. So how do we run this? Well, all we have to do is assert equal Pathfinder service. Oh, sorry. Expected path first, because you always want to put your expected value first. And then Pathfinder service dot find path. And then Pathfinder service takes in 3 values. It takes in origin, target, and map. Whew, okay, so maybe that felt like a lot to work on, but this should work, and it is kind of a really non-trivial test to write. Let's run this. So let's first refresh our tests. There we go. This is the fake stub up there, but this one, if we run it, it fails. Why did it fail? Oh, okay. Why has it failed? 1, 0, 2, 2. Oh, okay. Target was not the one I had thought, so it went all the way around here. So if we change that to 2, 0 and then run it. Aha! Okay, so that worked. Okay, cool. So now basically what we're going to do is just copy and paste this for every other thought we have for what a Pathfinder could do. So let's run a few unhappy paths here. What if the origin and the target cannot meet up? What if they're blocked off from each other? So let's do blocked path. So we'll look here. The return value for that is going to be, I believe, null. Yeah. So a failure gives you null. So in this case, we will edit our map to look like, let's say, something like this. So now there's a wall between 1 and 1 there. We can keep the same origin and target. That's just fine. And then we will, expected path in this case is going to be null. It doesn't like that just because it's going to already be It doesn't like that because it would rather have assert null, so that's fine. Assert null is just assert equals null. Okay, cool. Let's run this one. So this one should pass because this will return a null. Grab it. Beautiful. Okay, that worked great. Okay, so that's one possible thing. What if the origin isn't even on the map? Let's see what happens then. So let's take our happy path here again. I'm going to delete this top one because we're just copying the other one now. This doesn't like that, so let's have a look at what we'd expect. So I think isLegal tile, let's see what that is. So isLegal tile will check this for us, so we can test that. So we'll go to 3.0, should return null, I think. So in this case, we can use the same map. We can change this to 3.0, which is an address that's off of the map. And expected path, again, is going to be nothing. And we'll change this to assert null. Okay, cool. Let's see if this works. Why is this mad? Oh, we forgot to give it a fact. Very nice. Okay, let's see if that works. And it does. Okay, cool. So giving it a address that is over here off the map now fails. Beautiful. One more quick one we can test for kind of an unhappy path is copy and paste everything. What if the target and origin are the same? So what is the return that I give for that? Null. Origin equals target. Okay, awesome. So let's do that. So we'll use the same map, whatever. If you find yourself actually reusing the same thing over and over again, you could make a class variable for it. But in this case, we're going to end up changing it a bunch, so it might be clearer to do this. In this case, also, origin and target are the same, so it should return null, and that is that again. Let's do a quick test. Excellent. Okay, so that's a lot of the unhappy paths. Let's find a few more happy ones. So I'm going to grab this one again. What about a more complex path? So what if it has to go all the way around something? So what if there's a bunch of -1s in the middle here? We try to like line this up so you can read it as a map. In this case, we'd expect it to go here, and then 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 here, which is going to be a bit of a pain to write our expectation for, but not that bad. And we'll call this complex path. Very nice. Okay, cool. So let's write this one here. So we can keep the same origin and target. That's all great. Expected path is going to be annoying to write, but we could just run it and fail it and maybe copy that. Let's see if that will even work. I don't know offhand. So this will fail. Good. Yeah. Okay, cool. So it gave us actually almost all of it. So why don't we just copy this? Totally okay to do. Oh, you know what? It won't because we need to... Oh. Is that going to give me vector 2i's? I'd be very happy if it did. This is syntax I don't recognize if it does. No, it doesn't like that. Okay. Okay, we'll have to... I'll just copy and paste this a few times. This is something I would really love in C#. The ability to have like just parentheses where I can put a value in for a value that is where we know the type. You know what I mean. it would be very more clear to read than a lot of these constructors. Okay, so this should this should pass now. Okay, cool. So now we have a more complicated path. And then there's one more I want to try, and that's to see how it deals with if the numbers are higher, if there's difficult terrain or whatever in between stuff. So let's grab this. Let's copy it, paste it. I think I'm going to have it do the same path because, and make a big number there. Now, if it was ignoring the difficulty values of the terrain or the values here, you'd expect it to just do this to get there. But if it wasn't, you'd expect it to go because this is 1, 2, 3, 4, 5, 6, which is cheaper than 10, 11, if that makes sense. Cool. So let's run this. Oh, it doesn't. Oh, sorry. Yeah. With difficult terrain. And that passes. So this is great. Now, we look like, how do we know what branches have been tested here? And we actually have a tool for that, which is cool. So we can see how accurate how not consistent, but thorough we've been. So to do that, go to the top here to your whatever group of tests you want to check, and then click Run Tests with Coverage. And that will give you these this green highlight for wherever you have actually hit with your tests. And it looks like, I think I can go here. It'll say down here how much each class has been covered with this set of tests that you ran. And here we have 100%. So it looks like every single line, at least, has been covered. Now, this can lie a bit, or at least it can misrepresent. I think this, if you did any of these checks, it would have represented this line as fully covered. So don't trust this as if it's gospel. But it is a reasonable way to see if you have actually hit all of the branches in your code. And it looks like we have here. So I would feel relatively confident about this. I actually realized when I was writing tests for this that I had forgotten to add this function here. And that's why my tests weren't coming out. So sometimes you will find stuff you missed in your code when you're writing good tests. So we've actually got a lot of confidence now about our Pathfinder service without having to make a bunch of levels and do weird things in Godot or wherever our game engine is to see if it's kind of working secondhand. We've actually just tested it firsthand. So that's great. That's a good thing about tests. And if you have a friend, co-developer, or I guess Nemesis co-developer who goes in here and starts messing with stuff, this will catch them if it breaks stuff. So that's huge. Also, with this kind of thing, you might also start doing a little bit of work to improve performance. In this case, the unit tests will be a really great guard against you messing everything up, and you won't have to rewrite them because the input and the output are always going to be the same. You just might find ways to make it work faster. And refactoring also, that would help too. Okay, cool. So that's kind of the less trivial example I wanted to give here. And I think it's a good example of how you might test a little service like this. All right, now you understand how to write unit tests, and you understand why to write unit tests. And if you come back again, I will give you some advanced tips. We can talk about like the theory decorator in XUnit. We can talk about CI. Maybe we'll talk about how to get AI to write your unit tests for you, which is one of the good usages of AI for code, because let's face it, these aren't super glamorous things to write, but they are really useful, and I hope you understand that now. Anyways, write good code, and I'll see you soon.